Hello, this is Mrs. Myers, and we are going to be learning about conditional statements today. This is Unit 1, Lesson 4. This is really just the first half of the the lesson, and we will continue the rest of the lesson during class. So let's first start talking about what is a conditional statement. A conditional is an if-then statement. Anything that's written in the form if something, then something else, right? So if an angle measures 24 degrees, then it is acute. That is a conditional statement. Think of a condition, like if you ask your parents, can I go out Friday night? They might say, well, you could go out on one condition. Right? It's a conditional. They might say, well, if you clean your room, then you can go out Friday night. So it's conditional. The part that follows the if is called the hypothesis. Now, I know in science class you might have a different definition of that, but the hypothesis is the part between if and then. And the conclusion is the part following the word then. So it's important to notice that the hypothesis does not include the word if, and the conclusion does not include the word then. We're going to practice that in a little bit. Notice this circle over here. This is called a Venn diagram. You've probably seen them before. But the bigger circle is the more broad category, and then any smaller circles inside, sometimes you see them overlapping like this, like a Venn diagram would overlap like that. This one doesn't, not with if-then statements. With conditionals, you basically have one little circle inside a bigger circle. So the more broad category are acute angles, and the smaller category would be an angle that's 24 degrees. If an angle measures 24 degrees, then it is acute. So in the Venn diagram, the part on the inside circle is the if, or the hypothesis statement. Okay, and on the outside, the bigger circle is the more general, the conclusion. It's the then. So let's look at some other examples. Given the conditionals below, identify their hypothesis and conclusion and fill in the Venn diagrams. Okay, so if Joe lives in New York City, then, there's the if, there's the then, he lives in New York State. So we want to just take the part after the if, between the if and the then. That's the hypothesis. So we're not going to include the word if. I can't stress that enough. You don't put the word if when they ask for the hypothesis. You're just going to copy what comes after the if. Joe lives in New York City. And the conclusion, again, we're not going to include the word then. We're just going to copy what comes after that word. He lives in New York State. So, based on our parts of the Venn diagram, the hypothesis, the if part, think if begins with I, and inside begins with I, so the if part goes on the inside. So, Joe in New York City. So New York City is the smaller category. And then the bigger one would be New York State. So living in New York State. All right, if angles are adjacent, then they share a vertex. Hypothesis, again, the part that comes after the if. angles are adjacent. Conclusion, they share a vertex. Okay, so you try filling in your Venn diagram there. All right, so inside here you should have adjacent angles, and on the outside you should have angles that share a vertex. Because there's lots of other types of angles that could share a vertex. Even vertical angles share a vertex, right? So adjacent angles share a vertex. Vertical angles, I could put another circle in here with vertical angles, right? Because they share a vertex also. They're in the broader category. But for this if-then, it would just be adjacent on the inside and share a vertex on the outside. Okay, so you can practice writing your own conditional. You can come up with anything you want there. If it rains on Saturday, then I will go to the movies. Whatever. Come up with your own, and you can write your hypothesis and conclusion. Okay, so sometimes there are statements that are not written as if-then statements, but they sort of imply a conditional situation. So these are some examples of that, and we can practice writing these statements as conditionals, as if-thens. So dolphins are mammals. It's kind of implying that all dolphins are mammals, which kind of implies that if it is a dolphin, then it is a mammal. So your hypothesis would be it is a dolphin. Your conclusion would be it is a mammal. Your Venn diagram would okay, my smartboard stopped working here. This is not good. Oh my goodness. All right, so vertical angles share a vertex. I'm trying to fix my smartboard at the same time here. Vertical angles share a vertex. This implies if they are vertical angles, then they share a vertex. So I was going to do the Venn diagram for the mammal thing. Dolphins would be in here, right? And mammals would be out here, because there's lots of other types of mammals. Okay. Now, the truth value of a conditional is basically deciding whether it is true or if it's false. If it is false, then you can come up with what's called a counterexample. Only if it's false. So let's look at these conditionals. If you are playing a sport, then you are playing lacrosse. Is that true or false? Now remember, for something to be considered true, it has to be considered always true. If you can think of a situation that would be different than this, then it would have to be false. So if you are playing a sport, then you are always playing lacrosse. Is that true? No, of course that's false. What might you be playing instead? You could be playing football. So the counterexample would be playing football. All you need to do is come up with one instance that makes this conditional a false statement. Let's look at the next one. If a pair of angles form a linear pair, then they are supplementary. If a pair of angles form a linear pair, then they are supplementary. This is actually true, because all angles that form a linear pair have to be supplementary. I can't think of an example of a pair of angles that are forming a linear pair that are not supplementary. Therefore, there's no counterexample, so this thing is false. I mean, it's true. That's a true statement. Okay, to find a conditional's converse, what you do is you switch the if with the then, basically, the hypothesis and the conclusion. So for each statement, write the conditional, the hypothesis, the conclusion, and the converse. Then state if the conditional and converse are true or false. If false, give a counterexample. So you have a giraffe is an animal with a long neck. The conditional would be if it is a giraffe, then it is an animal with a long neck. Is that true or false? That's true. Giraffes all have long necks. Counterexample we can't come up with because all giraffes have long necks. It's true. Hypothesis. It is a giraffe. Conclusion. It is an animal with a long neck. Now remember, you don't include the word if or then when you're writing the hypothesis and conclusion. The converse is if, okay, now we're going to switch the hypothesis and the conclusion. So here we have the word if, here we have the word then, here we have the hypothesis, here we have the conclusion. Well, when we write the converse, what we're going to do is still have the word if and the word then, but we're going to put this conclusion over here as the hypothesis, and we're going to put this hypothesis over here as the conclusion. So you're just switching their places. So you want to just copy exactly. So I'm copying this conclusion over here. It is an animal with a long neck. If it is an animal with a long neck. That's going to become now our hypothesis. Then, okay, so now we're going to take this one and put it over here. It is a giraffe. So our original conditional was, if it is a giraffe, then it's an animal with a long neck. And now it's going to say the converse, if it is an animal with a long neck, then it is a giraffe. So notice that the conditional was true because all giraffes have long necks, but the converse is going to be false. If it is an animal with a long neck, then it's a giraffe. Can you come up with a different animal that has a long neck? So I can think of a goose. A goose has a long neck, and it's not a giraffe. So my counterexample would be the example I can come up with that sort of makes this, proves that this is a false statement. Okay, that's as much as we're going to do on this video. We're going to continue with this lesson tomorrow.